There are many interesting things that you can do with two magnets. Look what happens when you bring the north pole of one magnet close to the north pole of another.
It pushes it away.
The same thing happens when you try to move the two south poles together. But what happens if you bring the south pole of one magnet close to the north pole of another?
They move together.
Two poles that are not alike attract each other, while poles that are alike push each other apart. Magnets come in different shapes. Magnets like this one are called bar magnets. This magnet is called a horseshoe magnet. The north and south poles are located next to each other at the end of the magnet. This magnet is round. The north pole is on one side and the south pole on the other. What do you think will happen if you put the north pole of one round magnet on top of the north pole of another round magnet?
It floats.
The magnet floats because the north poles of two magnets push each other away. This is an experimental train in Japan. Unlike other kinds of trains, it doesn't have wheels. The train doesn't touch the track, it floats above it. Magnets keep the train from touching the track, just as the north poles of the two round magnets push each other apart. Here's another problem. This bar magnet has its north and south poles marked with the letters N and S. But this bar magnet doesn't have its poles marked. How could you figure out which pole is the north pole and which is the south pole? Your teacher can pause the video here. How can you figure out which pole is the north pole and which is the south pole? Try holding the north pole of the marked magnet near one of the poles of the unmarked magnet. If it pushes it away, then that unmarked pole is also a north pole, because poles that are alike push each other away. If an unmarked pole is attracted, then that pole is the south pole, because unlike poles are attracted to each other.